Hello everyone, my name is Gerald. Today I'll be presenting our work on the review of recent engineering developments in land-based aquaculture. So basically I'm going to talk about various technological advancements from engineering perspective, including the technology that have been already implemented or integrated in the aquaculture system, as well as the technology that can potentially be used in aquaculture system. A little bit of a background. 50 years ago, capture production was the main sector that contributed to global fishery industry production. However, with technological development, aquaculture industry is significantly increased both in scale and production. As is shown in the graph, that aquaculture production has produced nearly as equal as capture productions. But on the other hand, over the years, we can see that capture production has remained stagnant. The table below also support the data by highlighting the decline in capture fisheries over the years. It most likely due to factors such as climate change, overfishing, COVID-19 in 2020, and various political situations. But on the other hand, we can also see that aquaculture industry has shown steady growth over the years. From this data, it is clear that aquaculture industry will become primary source of our fishery production in the future. Uh, as the industry grows, it is more important for us to develop efficient and sustainable aquaculture systems. Uh, One way to achieve this is by adopting precision fish farming concept by integrating technologies into the aquaculture systems. Therefore, in this presentation, I'm going to present various enabling technologies that support this adoption. This is the outline of the presentations. Basically, it consists of four main parts. First is fish technology, which cover the technology that enable us to observe the fish both physically and mentally. Second is feeding technology, where I will discuss about technology used to improve feeding efficiency. The third is the water quality technology. In this part, I will present work about technologies to monitor and control the water quality. And the final part is wastewater treatment. This part is about the technology that enable us to reuse the water, reduce the water usage, and minimize environmental impacts of the discharge water. Another important aspect of aquaculture, such as tanks innovation and energy utilization, is not discussed in this review. First, I'll start with fish physical monitoring. First, we have detection and counting system, which is a basically system to identify and count the number of fish in the tanks. Next, we have size estimation system. The difference between the current research and the research in the past is that current research employed segmentation instead of creating a bone-like structure of the fish to estimate the size. The last innovation is multiple individual fish identification. So it is basically a system that could help to monitor something like growth rate of each fish separately. Next is we have a research that address more complex tasks. First, we have the system that can detect overlapping fish in the view. Next, we have system that can detect physical abnormalities in the fish, like a pigmentation disorder, for instance. Next, we have system that could identify disease in this disease. In this example, we have streptococcal infection and nocardia infection. And the last, we have the system that can detect fish mortality at the bottom of the tank and sending real-time notifications to the fish farmer. Next, we move on to tracking and behavior monitoring, which is crucial for understanding the fish behavior. First, we have the system that could track the movement path of the fish. Next, we have the system that could detect various fish behaviors, including feeding patterns, response to hypoxia or low oxygen conditions, hypothermia or low temperature conditions, fractioning reactions, and normal behavior, which could provide valuable insight for the farmers. And last, we have development of an acoustic based approach using hydrophones to enable us to detect fish behavior in low light conditions through sound analysis. These are the technologies used to develop fish-related technologies. It can be seen from the table that the most of the research utilize the YOLO, you only look once algorithm for the task, and they add in convolutional block attention module or CBIM at the backbone, and path aggregation network or PANet at the neck in order to improve the performance of the model. The next part is feeding optimizations. So from our review, we found out that research on feeding optimizations basically divided into two categories. First, researchers try to optimize the amount of the feed given to the fish, And the second, researchers try to optimize the feeding interval or feeding time window. Uh, Various research focus on improving feeding system efficiency by detecting and analyzing different parameters, as can be seen in the table. These studies mainly utilize computer visions and deep learning technology to improve the feeding process. Now let's take a look at some research on feeding optimizations. First, at the left side, we have the system that use hunger degree of the fish to determine the feeding. The hunger degree is classified into three categories and feeding is provided accordingly. On the second system, at the uh, top right, we have the system that detect uneaten pellets to adjust the amount of feed for the next feeding cycle. And at the bottom right, we have the system that combine both hunger degree and uneaten pellet detections to determine interval for the next feeding. Additionally, another approach have been made to optimize feeding. Instead of detecting uneaten pellets or fish behavior like the previous system, this system detects the waves produced by the fish while eating the feed to determine the duration of the feeding time window. The next part is water quality maintenance. So basically, we will talk about water quality technology that consists of two parts, namely monitoring and controlling, where monitoring can be further divided into direct monitoring and prediction. The direct monitoring system uses Internet of Things concept to remotely monitor water quality. On the left, researchers implement narrowband IoT or NB-IoT, which use GPRS to enable wider applications and utilizations. On the right, they implement AIoT or artificial intelligence of things, which allow the system to not only detect but also predict the future water quality values based on the collected data. Next, for the predictions, we use dissolved oxygen as the case since it is the most commonly predicted parameters. As is shown in the table that various models have been developed to predict the dissolved oxygen value. Each has its own strength, which measured by the performance metric. Uh, Out of all the models available, GRU or Gated Recurrent Unit model can be considered the best overall performing models due to the complete parameters and superior performance in MAPE and R squared. And also it has a balanced performance on other metrics. So the next is water quality controlling, which is aeration devices. So improvement in this sector are mostly achieved through mechanical modifications. So researchers try to modify either the direction of the aerator system or the coverage of the aerator system. The final part of this presentation is wastewater treatment, specifically the filtering system in use in aquaculture. This is the typical filtering process of the aquaculture system. First, the mechanical filter serves as the initial stage to remove solid waste such as uneaten feed, fecal matters, and debris. Second, the biofilter is used to eliminate organic waste such as ammonia, phosphate, and organic compounds. There are two commonly used mechanical filters, uh, namely micro screen drum filter and sand filter. On the left, the micro screen drum filter has been improved with self-cleaning mechanism in order to reduce the power consumption. And on the right, researchers try to integrate slow sand filter with another mechanical filter such as rapid sand filter and wetlands to improve the filtration efficiency. Another type of filter is biofilter. So biofilter is basically a filter that functions by utilizing living organisms to remove the waste. In the upper left, the system utilizes moving bed biofilm reactor or MBBR that use bacteria for the filtrations. And in the bottom left and right, the system use microalgae through phytoremediations or can be simply put as algae cultivations for the filtration, while they also producing the biomass which can serve as an alternative feed for the fish. Finally, we come to the conclusion. We have seen various advancements across various sectors of aquaculture. These advancements enable us to perform tasks efficiently and effectively. We can conclude that by integrating these technologies, we could achieve the final goal of sustainable aquaculture system, which means we can maximize the fish productions while minimizing the cost and ensuring the environmental friendliness. So that's all from our team. Thank you very much for watching. Have a nice day.